Today we learned about the properties of a parallelogram. Parallelograms have two parallel sides here. Oops, sorry, that's the symbol for congruent. They have two sets of parallel sides, here and here. Opposite angles are congruent, and opposite sides are congruent. So if you look at your quadrilateral table from today, we filled out all the properties of a parallelogram here. And don't forget that here is where we talk about sides. Here is where we talk about angles. And here is where we talk about diagonals. And you should have this written in your table. So when you're looking for the property, when you solve a problem, it's right here and it's easy to see. So if you look at the parallelogram here, we only have to prove one property in order to prove a figure as a parallelogram. And that is that opposite sides are parallel. In a rectangle, we had to do this and prove that all four angles were 90 degrees. And then we'll go on the other properties that we have to prove for a rhombus and a square. But basically, the parallelogram has the least amount of properties, and the rectangle has two properties you have to prove. The rhombus has two properties, and the square is the best figure. It has the most properties. So let's try to apply these properties to solving equations. So in this one here, we're talking about a diagonal here, a diagonal here, a diagonal here, and a diagonal here. So we are talking about diagonals. So we're going to look at our diagonal section on our parallelogram properties and see that there's only one property we can use. And that property is that diagonals bisect each other. So what do we mean when we say that diagonals bisect each other? That this piece here is equal to this piece, and that this piece is equal to this piece. So we use that knowledge to create our equations. So 2x plus 3 equals 5x should be our first equation, because this piece here is equal to this piece here. And then our second equation should be 8y minus 36 equals 4y, because this piece here is equal to this piece here. So now we solve. We get the x's together. And we get x equals 1. Over here we solve for y. And we get y equals 9. So here, even though we had two variables, the y's were together and the x's were together. So we did not have to set up a system of equation. We just solved x over here and solved y over here. Next, it says if wx by z is a parallelogram, find and use the property used. So, first we know it asks us for WZ. WZ is a side. It's this side right here. So we know that we are talking about sides and that opposite sides are congruent will be the property that we talk about. So we get 42 plus x equals x squared. Minus x, we get 42 equals x squared minus x, minus 42, minus 42. And here I get a quadratic. So I can do one of two things. I can either factor it, or I can do quadratic equation. Ooh. So let's factor first. So we have A equals 1, B equals -1, and C equals -42. Up here we get A times C, which becomes -42. Down here we do B, which is -1. So we're looking for the factors of -42 that add up to -1, and that will be -7 and +6. -7, +6. Those become my factors here. I solve and I got x equals 7, x equals -6. Are we done? No. The question says we need to find side WZ. Side WZ is x squared. So I test out side WZ here and I get 7 squared equals 49. I plug this into WZ here. I get 6 squared equals 36. And that is my answer, 36 or 49. What if I use quadratic equation? I'm going to use the same A, B, C values over here and just plug it into the equation over here. I get x equals -1 plus or minus the square root of -1 squared minus 4 times 1 times -42. And here I get, and it's all over 2 times 1. So I get x equals +1 plus or minus the square root of -1 squared gives me +1 minus 4 times 1 gives me 4 times -42 gives me 168. So minus a negative gives me plus. I get 1 plus 168. I get 169 over 2. The square root of 169 is 13. So I get x equals 1 plus or minus 13 over 2. X equals, oh, whoops, this needs to be a plus. 1 plus 13. This is 1 minus 13 over 2. Here I get -6. Here I get 7. So I got the same answers here that I got when I factored. I just substituted over here. I'm not going to do it over here. Okay, so now they want me to find the measure of x, of x, y, z. So this angle here. Well, in a parallelogram, I know that these two angles are congruent, so I'm going to name this one here x and this one here x. And then look, this is just part of this triangle here. I have this angle, and the third angle. So I'll just make a little equation over here and solve for my missing angle. And I get 114 plus x equals 180 minus 114 minus 114, and I get x equals 66 degrees. Let's do one more. So we want to find x and y and state the property used using the figure. So let's look at the figure. What property are they talking about? Sides, angles, or diagonals? Well, since the numbers are outside of the figure, they're not here and they're not here, I know that we must be talking about sides. So let's look at our side theorems. We have opposite sides are parallel. That doesn't really help me. Or we have opposite sides are congruent. That definitely helps me. Now I use that property to create my equations. I have this side here going with this side here, and then I have this side here going with this side here. So I get 20 equals, pardon me, 20 equals 4x plus 2y, and then I get 11 equals 5x minus y. So if you'll notice, I have x's and y's together, which means I'm going to have to do a system of equations. So I want to get everything in the order of x, y equals a number, because that's the easiest way to solve a system of equations. So I'm going to do a little rearranging here. We're going to do 4x plus 2y equals 20. And over here, I'm just going to do 5x minus y equals 11. I'm going to bring this over here. I get 5x minus y equals 11. I do my brackets. I bring this here. 4 goes down here. 5 goes up here. I multiply through to each part. And I get 20x plus 10y equals 20. Ooh, excuse me, I committed the cardinal rule. 20x plus 10y equals 100. And then here I get 20x minus 4y equals 44. I make brackets, I subtract, these cancel. I get 10 minus negative 4 gives me 14y equals 100 minus 44 gives me 54. I divide by 14, I divide by 14. This cancels, I get y equals 4. So now I have y, and now I substitute y back into one of the original equations. So let's use this one. I get 11 equals 5x minus y. I substitute this 4 value in for y, and I get 11 equals 5x minus 4. I combine like terms. I get x equals 3. So these two answers are C. And let's do one more. So now here it says find x and y and state the property used. Well, the property used, let's see, they're talking about angles here. So the only property I have for parallelograms is that opposite angles are congruent. So this one will equal this one, and this one will equal this one. So let's write our property. Opposite angles are congruent. And let's set up our equation. We have 5y minus 9 equals 3y plus 15. Then over here we have 7y minus 11 equals 5x plus 29. Let's move this over here. I get 5x plus, let's see, 1, 2, 3, plus 40 equals 7y. And then over here, let's simplify a little. Plus 9, I get 3y plus 24 equals 5y. So I have y over here and I have x and y over here. I'm going to solve for y first over here and then substitute it back into this equation over here. So let's do that. Minus 3y minus 3y. I get 2y equals 24. Divide both sides by 2. I get y equals 12. So now I'm going to substitute that 12 back into the original equation. So let's use the original equation. 7y minus 11 equals 5x plus 29. So 7 times 12 minus 11 equals 5x plus 29. I want to simplify my answers, and I get 84 minus 11 equals 5x plus 29. 84 minus 11 is 73 equals 5x plus 29. Minus 29 minus 29, I get 5x, equals 44. Divide by 5, divide by 5, I get x equals 8.8. This is wrong, it's 8.8. Okay? So my answer here is x and y.